So thank you very much, Justin, for taking this session. Youssef has been wanting to learn about smart contracts and developing in Web3 for a very, very, very long time. He's been
Mhm.
one of the best students that we've had in Blockchain Sensei. So I thought, okay, cool. Let me find someone that I feel has definitely got the skill set and has definitely got the experience of building in a corporate setting. So yeah, I thought I'd use this session to do an intro for you guys to each other. There was a couple of other people that were interested, but they just didn't have the availability for 11 o'clock today. But that's fine. We'll just arrange another session. I'm hoping to make this a bit of a regular thing, probably once every 3 months or something like that. We'll do something like this. So yeah, Yusuf, you want to introduce yourself, and then Justin, if you go after.
Absolutely. So I'm Big Things, so sorry about that. So Justin, so basically I'm a software developer by trade. So I've been doing this for about 15 years. So I worked obviously mainly in investment banking, so BNP, JP Morgan for about 8 years. So implementing .NET applications, and now for the last few years it's mainly based around Python. So I'm doing a lot of Python, REST API, web services, and so on. That's what I've been doing so far. And obviously on the side, I'm doing a fitness coaching and trading. That's why I know Michael from. Obviously, he's been my my main teacher on how to get into into trading. So that's pretty much about me.
Brilliant. And then Justin, if you want to introduce yourself, and then get started when you're ready.
Hi, I'm Justin. I'm a freelance developer, full stack. Um, n- I know a little bit about blockchain, but not that much. But I usually do MVPs, and people are increasingly asking me about blockchain. So I've learned, and now I'm going to do some tutorials.
Well, hey, brilliant. Okay, okay. And then yeah, Justin, I'll let you lead the way. We'll try and keep this session to 45 minutes to an hour.
Okay. So first off, how's everyone doing?
Oh, good, oh, good, oh, good.
Very good.
Okay, cool. And to be quite honest with you, I didn't know what the experience of people was going to be on this call, so I decided to make this as easy as possible and to follow.
Mhm.
Um, so what we're going to be looking at is Remix and Ethereum and Solidity. Solidity, excuse me. Um, and we're going to be making a smart contract that we can use for a get coffee app in the future, possibly. Again, what you're looking at are the default that come with Remix.
Okay.
So we can delete all of these. Um, and again, if we do go further on, we can make some scripts and do some other stuff with those.
Okay.
But yeah, let's just delete all those. Right, so we've only got one. Okay. Now, what can you see on my screen now?
You've got the buy me a coffee, the home, a green play button, and then on the left-hand side, you've got scripts deploy with Ether, deploy with Web3.
Okay, great. That's brilliant. Because now what can you see?
SBDX dash license identifier colon on license.
Great. Okay. So that's the first thing you need to write when you're writing a smart contract in Solidity. Um, Usually, if you don't write that, it doesn't work. Don't ask me why, but it doesn't work.
Okay.
Um, the next line is simply to, when you're actually, I'll just write it. You need to know what version of Solidity you're actually using. For this, we'll be using 0.800. Anything like 0.01 or 5 should work with it. So if you do 0.8.5, it should work. But if it doesn't, just go to 0.800 and it should work. I'm going to go further on to that when in a minute.
Okay.
By the way, this is one of the first times I've done this like this, so do forgive if I'm not communicating correctly.
No. You're communicating amazing. For someone that's, I don't code at all, so this is amazing for me.
Cool. Right now, what we're actually doing now is we're building a smart contract, and everything should go in here. So let's just begin. Right. And what I'm going to do is try to go through each section so that you know what it is. Okay. So now what we're going to do is make an event. I'm just going to put that there. Oh, and I'll try and save all of this to GitHub as well.
Okay.
Something like that. Okay. And I'll just copy that. Yeah, it's just I'm going to copy a couple of things because it's just easier. I'm also going to explain them. So what we're actually making is a a smart contract that basically asks you for a message, gives a timestamp if you pay me. So what it will take it will take your address, it will take the timestamp, and that's every time it makes a new memo.
Okay.
That's the event. Again, we have to build a structure, so we will just build that as well.
So why is the indexed bit in yellow as a total new?
Because it's just letting you know that that's indexed means that it'll be one after the other. So there'll be, you can have more than one, but there'll be it'll be in a row, like so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Index from no. I'll have to look at that one up actually. That's a question. Yeah.
Okay.
Now you stumped me.
Sorry.
It's all right, don't worry.
So I got to the structure. So the structure is it's going to ask for an address,
Yeah.
and then it's going to timestamp it.
Yeah, and name. Now what we're doing is we're making that the address, the person that actually owns the smart contract, that's who you're going to be paying. And this is going to be our list of memos. So that's just creating the array of memos. So everything that we actually make is going to go in here. So it can be read afterwards.
Mm-hmm.
We're now going to build a constructor. Right. Again, this means that the person that owns it, that's who's going to be it's going to be paying out to. And again, that will become more apparent when I actually run it. Okay.
Of the deployer as a payable address. So store the address of the deployer as a payable address. When we withdraw funds, we'll withdraw here. Okay, yeah, that's a simple instruction. Okay.
Yeah. Right. Let's create a function. Should work. This is basically, now you'll see public view returns. Obviously, you know, every time you actually do something on the blockchain, it actually costs money.
Mm-hmm.
This won't, because it's public view.
Mm-hmm.
So it's free. You're not actually, yeah, exactly. Right, and now we're getting into the kind of crux of the of what we're trying to do. So I'm going to build out the entire function to the end, I think. Yeah, let's just get it to the end. Okay. Here. Sorry. To buy copy. It's asking for the name and the message. And again, if the person hasn't used any Ethereum, it's going to come back with a message that says can't buy a copy for free. Once it's actually in storage, that's what it's going to push. And again, it's just going to admit this. We've built another function that allows you to withdraw the tips. So if we go over here, we've got to make sure that it's what 8.0, the compiler. So we'll just make sure the compiler is the same one. Let's compile that. And again, all of this is done in the browser, so it takes a bit of time, but I'm trying to go as fast as I could. Also, I thought it'd be good to run something off the browser as well,
Okay.
so everyone's got the chance of using it.
So this contract is now basically saying anyone that wants a coffee has to have sent more than 0 ETH to this address, and then they get a coffee.
Absolutely. Yeah.
And then it will store that in the memory, and that's in this bracket, the last bit at the bottom, add the memo to storage, and then it just keeps the message of the person that's sent the money and timestamps it on the block, right?
Yep.
Okay, cool. Yeah, I can read code. Woo!
Yay! It's that simple. Okay, right, so now it's compiled it. So let's see what we actually get when we deploy it. Right, so let's deploy this. And let's look at our deployed contracts. And what we can see are 3 buttons. One says buy copy, one says withdrawal, one says get memos. And those, again, that's the withdrawal function. The buy function is here, and the get memos function is over here.
Okay.
So, right. First off, so if we don't put any money into this, I'm just going to put my name, Justin. Oh, I spelled it wrong. Justin. And then, hi there. How are you? Let's send the contract. Yeah, so we've got an error that time. Right, and as you can see, the reason provided by the contract, can't buy coffee for free. And again, that's this line right here.
Okay. So you can't. So the codes automatically recognize that that's not the right function, and it's gone. You're trying to flirt with me, so you can't have a coffee for flirting. You need to send me ETH.
Yeah, exactly. So now what we're going to do, we're actually going to send some ETH.
Quick question, Justin. You know that MSG.value, that MSG, how does he know what's in there, if that makes sense? Is there a global variable somewhere? Or how does he know the balance of the account? Is that where the balance is stored, MSG?
Right. So, no. So what we have is this public payable here.
Mm-hmm.
And if you don't pay any money, then it won't run the code. So there's no value. It's not getting any value back. So that's the reason why, because it's not storing in the in that part.
Okay.
So it's actually saying, oh, because you haven't got any money, it's not stored, and that's why it's not giving it back.
Okay, so the public payables is the public payable waiting to receive the funds, or is that checking that someone's got the funds?
A little bit of both, because if you haven't got the funds, you can't pay, and if you haven't paid, then there's no message sent.
Okay.
So, as far as I'm aware,
No, that's
no,
cool.
that's the way it works. That's the way it works. So when we go to debug, again, I'll show you that. So it tells us what gas has been used, transition costs. We can see the output. It says now, Justin, hi there. How are you? And that's where it's from. And yeah, you can get everything else here. And then when we go get memos, we can actually see that again. So if we do debug, no, not debug, sorry, not debug, pull it down. Oh, Jesus. Don't you hate when things go wrong? All right. Okay. Where is it? There we go. So it says that's the output of the string, letting us know that that's the first timestamp. So if we do another one, we do another transaction with a different name. All right. And then we'll do, dude, where's my coffee? And then we'll put for transaction, and then if we get that, pull that down. Ah, where's the other memo?
The first one.
Oh yeah.
Oh, so sorry. I just want to go back a sec. So the first bit was the contract recognized that a payment hadn't been sent, and it stored the transaction. The request was stored on the blockchain.
Yeah.
Okay. Okay. Got it.
So say if there's no money on there, it won't do anything. It will just come back with an error, and that's the error.
And every request is stored on the blockchain. And where in this? Oh, okay.
No, not one.
Yeah. So it gets the transaction hash as the attempt.
But it hasn't actually stored that, so it hasn't stored it as a memo. That's not stored there. We could do something where it does store it, but we haven't done it on this one. It just gives you an error.
Okay, that's fine.
I've got a quick question, Justin. You know, when it comes to gas, don't quite understand what is this gas? Is it unit? So say the same way we buy euros or sell euros on Ethereum, we just pay gas fees. I'm not sure I understand this term.
I'm not sure I understand gas properly as well.
I can explain this a bit better. So the gas is measured in what we call wei, and then when you go to Ethereum gas station, it allows you to see what the current price of gas is, or what the wei equals to in US dollars. So then each transaction has a minimum of wei that you would have to pay, depending on how many transactions are happening in the network. So let's say, for example, there's only 1,000 transactions happening in the network. The wei might be like 3 wei, which might equate to like $5. Whereas if there's 100,000 transactions happening, then the wei might be 100, and then that works out to be about $500 that you have to pay per transaction. So every time that we sent this request for the coffee, or he was sending a message, it would have cost $500 depending on the gas fee at that time or how busy the network is.
Okay, but this remix software, can we get a desktop version, or is it on the browser? Because where's that stored? So when you say transact, where's that blockchain? Is it like a free Where is it
So
stored?
yeah, so this is Remix. It's a virtual machine. It's stored nowhere. Well, it's stored on their virtual machine.
Hmm.
But you can put it to either a test net or a real blockchain. But
Hmm.
we're not going to do that today.
Yeah.
Okay.
And if you wanted to, I think if in regards to exploring the blockchain, Yusuf, I'll do a separate lesson with you on how to trace transactions from wallets and stuff like that, because that's a whole separate lesson.
Yeah,
But if
today was only about basically making a what do you call it,
basic smart
smart
contract,
contract.
yeah.
Yeah.
And then in terms of security, so if I've got my own blockchain, my own contract, how do I make sure that no one can actually execute that contract outside of my blockchain? If that makes sense.
Well, you can do tests through Remix. I suggest you get the desktop version. And there's loads of. I'm just going to try and see if I can. You can do full tests for security on here. See, this blockchain hasn't got much on it, but it's definitely something you can do.
Mm-hmm.
Yeah. Well, it's debugging. It does tell you what it does give you data on there. But yeah, that's definitely something you should look into. And I'm finished.
Okay. Can you show us what it looks like when the string when it actually sends some ETH to the to for the coffee?
Right. Okay. Yeah. So I can. I can show you that on.
Because I'm wondering if it's as simple as, you know, like how you've done it when you've sent the message and then it goes, you can't buy coffee for free. Is it as simple as send one ETH and then it just recognizes that one ETH's been sent?
Let's have a look. Let's have a look. Um, so I've actually done this already. On a different. Let's see if I can get the right share. Can you see the ID? Is the screen moving up and
Oh yeah,
down?
yeah, it's moving now. Yeah.
Yeah. Okay. Right. So basically, as you can see, there's this has 100 ether. And what I'm going to do is I'm going to make sure that this is the account that I am going to compile this. And yeah, so it's a compiler on that account. Deploy it. All right, what was the question?
To see where what money's actually been sent and someone actually gets the coffee.
Right, okay. So as you can see before I started, there is a little bit of ETH taken
Yeah,
out
yeah. I see that.
Originally. Right, now what I'm going to do is I'm going to go to a different account. I'm going to go to this account, and then I'm just going to make this easier to see. So I'm going to put that on 50. Sorry, I'll just 50. Okay. And then I'm gonna say, right, uh, James Bond.
Shaken,
Hi.
not stirred.
My name is James. Oh, James Bond. I should have said no. That's what I should have said. Is Bond. James Bond. Oh, my typing is atrocious. All right. So that's the ether on there. If we make a transaction. Right. Okay. So the is there. And we can see on that account 50's gone. Now it hasn't gone back, it hasn't gone there yet because we haven't done a withdrawal. So once we do a withdrawal,
So this is now a user withdrawing that 50 from the smart contract.
yep.
Okay.
It's in the guys it's in the original
Oh yeah,
person.
it's gone. Yeah, I see it.
Yeah. So that's what it looked like.
Why is it not perfectly 50? Is there a reason why he's not 50 perfect?
That'd be the gas.
Yeah, that would be the gas.
Oh yeah, makes sense.
Okay, that makes sense. Okay. And then you know the script at the bottom, does that change now? How before the text said you did not buy a coffee or whatever it was. It was
No, now it's part of the memos. So the memo is so
oh, okay. Ah, okay.
it's right here. So again, if we're gonna be like cheap and don't send any money, it's gonna bring back that transaction here which says
Yeah.
can't buy a coffee for free. Right,
Okay.
so that's an error. Because when we stated in the code, we said that you basically got to do something. You got to pay something,
Yeah.
anything, but you got to pay something. And if you don't, you're going to get that error which says can't buy coffee for free.
Okay. So only when it's successful, it goes straight to the memo.
Yes.
Okay. And then when it's not successful, you get this message pop up.
Yes.
Okay. And then even if it's successful or not successful, there's still a transaction fee.
No, I don't. No, I don't think there's a transaction fee. No, there's no transaction fee if it's not successful. If they don't have any money, it won't do anything.
Okay. Is there a
I should
way of seeing, even if the transaction's unsuccessful, would there be a way of seeing any attempted transactions? So as the person that's created the smart contract, let's say, for example, I'm telling you, yeah, I did try and buy a coffee from you. Would you be able to now go and check the smart contract and go, oh yeah, I can see you attempted, but you didn't have any money?
that function can be written in, but we haven't written it in this.
Okay, cool. Okay, that makes sense. Oh, amazing. That's really, really useful. Yeah, you've given me a much better understanding of what when I'm checking wallets. Now I'm understanding the process that's going on with the handover of the digital asset and how it's doing that. Okay. So what I'll do is I'll take over. That was your bit done now, right?
Yeah, sure.
Amazing. Thank you very much, Justin. What I'll do now is I'll now go to the ETH block explorer and I'll show how we would find transactions and explore them. So in regards to when we was talking about the gas fees, the place to go to is just ETH gas station. So you just literally type ETH gas station and that'll bring up this. And this tells you the cost of gas fees at this moment in time, which I've just realized they are 7 cents. That is crazily cheap. Oh my god. Oh my god, that's crazy. Okay, I need to buy some stuff if it's if it's only that price. Wow. Okay. So yeah, I've seen these gas fees as high as like $44. So this is crazy to see that it's this low. So yeah, you can see the cost of it there. And then it shows you the total amount of gas for different things. So this is and this is the real-time gas use, the wait times, and there's loads of information here to explore. So let's go and so pretty much every wallet, every blockchain, the Explorer is the same. So if we go ETH Explorer, that'll bring up the Ethereum Explorer, and then you just type in what it is that you're looking for. Then if there's, say, for example, we was tracking a transaction we did on BNB, BNB Explorer. So you've got the Explorer version and then you've got the scan version. So the Explorer version is kind of like it does the same thing, but it's kind of like the UI is not as good. So you've got Binance Scan for scanning things on the Binance network. You've got ETH Scan for scanning things on the Ethereum network. And you can see this one's a little bit cleaner than the Explorer one. Let's say, for example, I was using something like Swissborg. You just go Swissborg scan. Okay, why has that not worked? Oh yeah, it's there. So yeah, because it's on the Ethereum network, you can scan it inside there. Let's go Polygon scan. My screen sharing, right?
Yeah, definitely.
Yeah. So Polygon scan, it's there as well. So it's the same way. So what you can do is you can just check for transactions that have happened. So let's use what I'll do is I'll use an example now of something in my wallet, one of my wallets.
So you could paste your own wallet transaction and see it on the scan, basically.
Yeah. Let me just find a wallet that I used to buy an NFT. So I've been messing around with this Coinbase wallet. So let me do that one. Okay, so what this should let me do, being as the Coinbase wallet is now it's by text now instead of like the long wallet address. So let's see. This is the first time I'm trying this, so let's see if it works. So I am Mr. Harding.cb.id. If not, we'll just find an NFT one and follow that one. No, it's not letting me check it. Okay, cool. So let's do just an NFT one. Let's just find someone on OpenSea, for example, and we'll have a look at someone's wallet. So, and you can see all the chains are there, and then you just basically select the scan for the chain. So if we want to go collectors. So let's say, for example, these Donald Trump ones that have just come out, right? Let's see who's been buying them. So we've got activity. Okay, cool. So we can see here's some sales and some resales. One 37 seconds ago, 49 seconds. So it's quite active. So let's go with this one here. And we click on it, and it'll bring up this person's wallet, their account on here. And these are all the things that this person's holding in their wallet on OpenSea. So then what we can do is we can get the address. So we click the address, and then we go to ETH scan. There we go. And now we can see what's been happening in this wallet. So we can see this is the value that's in the wallet at the moment. We can see the transactions that have happened. So there's been some stuff they've been doing with Polygon as well. You can see when the wallet was created and stuff like that. So again, this is just something you'd want to play around with. Just go on OpenSea, find a random wallet, have a play around with it, and then you can see the other tokens that have been held in this wallet. So you can see there's $1,000 of wrapped ETH. There's $3,000 of USDC, $12 of Matic. And then you can see the other NFTs that this person's holding, and then the other types of tokens that they've got. Cool. And then yeah, that's the way that works. So then as well, another way of doing it with a slightly better UI is zapper.fi. If we take that same address and we pop it there, it should, yeah, there we go. It'll bring up the wallet, and then it should calculate. Yeah, you can see it's saying syncing, and it should calculate what's in the wallet, and it should show the NFTs that this person's got. So yeah, we saw on the ETH scanner that this person had 2 Goblin Towns. So it's now showing the wallet, how much is in the wallet. It's now showing the NFTs that are being held, and then the type of NFTs that they are. And then if we wanted to, it should let us see the transactions that have happened on each network. So personally, I prefer zapper.fi. I think it's just a really clean UI UX to track wallets and to see what's going on. So yeah, that's that. Have some fun with that. Any questions on wallet tracking, transaction tracking on ETHScan?
I'm just surprised that you can actually view anyone's wallet content. I thought that was not confidential, but if someone's got $1 billion in his wallet, then anyone can. I wish he's secure, but I wasn't aware that this type of information was publicly available.
Yeah, that's the whole point of it, is that it's publicly available, and this is why everything that's happening in the law with FTX and Binance and all these companies at the moment is quite interesting, is because people are watching these wallets all the time, the biggest wallets, and going, oh, okay, well, this person's just moved $1 billion. Why have they just moved $1 billion? Whereas with traditional finance, you can't see when you can't see when HSBC has moved $2 billion.
Yeah.
But the way that the lawmakers are making it seem is as if, oh, it's really bad, these crypto and these blockchain people, they're really bad. Look at them like defrauding people and whatever. And it's like, no, the only reason people realized they were getting defrauded is because they were checking the blockchain. Whereas people can be getting defrauded all day, every day in traditional banking, and they would never know.
Yeah, absolutely.
So this is where it's a bit different. So yeah, let's again, if we look at some of the biggest NFTs on the planet. So if we go all NFTs, if we go rankings. So we know, let's say for example, CryptoPunks. Oh, there we go. So CryptoPunks, we know those are selling for like 289 ETH. Some of them are selling for a couple of million. So this one's what, 60 ETH. This one last sold for 150 ETH, 142 ETH. So this, when you start doing the wallet tracking, you start realizing, hang on a minute, there's only certain people that are actually making a lot of money. So here we can see the transfer and the sale history of this one, and who it was from and who it was to. So we can see this person, Millennial ETH. Let's go and look at their wallet. These are the NFTs that they own. You can see they've got a few Goblin Towns as well. But now let's go and have a look at their total wallet on Zapify. And then when I've been doing this, some of the wallet accounts are crazy. There's literally wallets that you're just looking at that are buying these NFTs that apparently are for normal everyday people, but they've got like 500 million of ETH in their wallet, and you're just like, that's not a normal everyday person. And again, the only way that you could track this is because of platforms like this, and because of the blockchain. And this is what I think is slowing down a lot of the progress of things, because this kind of ability for ordinary everyday people to be able to look into wallets like that is amazing. So yeah, we can see this person's got $263 of crypto, but it's got 165 200k worth of NFTs. So this one seems like more like a real person. Whereas if we go back to the activity history on, normally once you keep going back through the activity history of like who had it, so we can see, let's go 2 years ago, JMG bought it. So let's go and look at JMG's wallet. Copy, go to Zappa.fi. And it should bring it up. There we go. Yeah, 176k. So this one's a little bit more normal, to be fair, as well. But yeah, and then it gets even more interesting if when you go to CoinMarketCap and you can click on a token. So let's go let's go ETH. And then it normally on CoinMarketCap shows you the top, the token distribution. So if we go more info, yeah. Okay, it's not fully doing it there. Let's go wallets. Okay, maybe not that one. Let me do it with one that I know that we can do it with. So we can do it with Kronos. Here we go. So you can see here the top addresses. So we can see 93% of crypto.com is held by just 10 people, which shows that it's not decentralized at all. So then what we do is we take some of the addresses. So we got like this address here that owns 3%. And then we would go to the Crow scanner. I don't know if this one works on Zapify, but let's try. Oh yeah, it does. Yeah, there we go. So we can see here that this wallet is holding 187 million worth of Crow and just $103 of ETH. So we can clearly see that this person isn't that active in crypto. And then if we wanted to, we can see when the last transactions on ETH on this wallet were. So we'd be able to see how active this owner of all this actually is. So if we go activity, October the 10th, 2022. You can see the transactions for the Crow as well. So this is why this stuff is so powerful in terms of tracking behavior and misbehavior. So yeah.
Wow. Awful stuff.
No worries. But yeah, now what Justin's shown you earlier now makes sense of what I've just shown you, if that makes sense. So what I've just shown you is the front end. What Justin's shown you is the back end. But why it's important to know the back end is because the front end can be manipulated.
Yeah. Yeah.
So yeah, that's why it's super important. But yeah, thank you everybody. Great session. One for the history books. Yeah, let's try and get another session in a couple of weeks, just after Christmas.
Yeah, sounds good.
Absolutely enjoyed it. Thanks for having me.
No worries. See you later, guys. See you in a bit. Bye.
Yeah, bye.